So part two of this video for vectors is finding a unit vector in the direction of v is what we just did in class. So picking up where that left off, I want to talk about the standard unit of vectors and what that means and that sort of thing. The standard unit of vectors is you can have two vectors, and if you have the first one is I is 1 0 and j is 0 1, those are the standard unit vectors. And if you notice, it's because if you take it, it's like x comma 0 and 0 comma y. Um, any vector v can be written as expression in terms of the standard unit vector. So if I make v equal to a comma b, I can say, all right, a comma 0 plus 0 comma b, factor that out. A is 1 comma 0 plus b 0 comma 1. So the standard unit vector is ai plus bj. Okay? Here the vector v, a comma b, is expressed as a linear combination. So technically this part right here, that part right there is called the linear combination, because if you put it together it will make a line, so to speak. Right? So this is technically called a linear combination. So this is a linear combo. Okay. So this is a linear combo, and what did I say? A I plus B J is the standard form of a vector. Standard form of a vector. All right. So that's the standard form of a vector. Now, basically what that means is the scalars a and b are the horizontal and vertical components. So, what does this look like? All right. So, if I had vector, if I had vector a b, so what does this look like in the coordinate plane? So, if I had vector a b, this would look like that's vector a b right there, right? But when we say that the a is the horizontal and b is the vertical components, this little bit right here, this is the AI part, and this little part right here, this is the BJ part. That's the vertical part, if that makes sense. Okay, so the next thing we're going to talk about is resolving the vector into components. So I have, this is a terrible writing, so I'm going to write it again. I'm going to read it to you. If V has direction and angle theta, the components of V can be computed using the formula V equals the magnitude times the cosine of theta, comma, the magnitude of the vector times the sine of theta, if that makes sense. All right, so from that formula, you can make the unit vector in the direction of v. You remember the unit vector was this, v over the magnitude of v? Well, if you have that, you can realistically just say that that is equal to cosine theta sine theta, if that makes sense. So we're going to try it. You ready? All right, so find the components of the vector v with the direction angle 120 degrees and magnitude of 8. So what does this look like? I would draw this out. So if I do this, I got this guy right here. Here's 0, or that's my origin, and 120 degrees. So if you remember that, it goes out probably like that. That's 120 degrees. And then this is going to be vector AB. So what am I going to do I guess that's magnitude. So this whole distance right here is 8. All right. So we know that v is equal to a comma b, right? Because that's our vector. So I'm going to fill it in. I'm just going to say then that's going to be 8 cosine of 120 comma 8 sine of 120, if that makes sense, right? So then I can use my calculator in this case to get, I'll allow you to use your calculator, even though I think 120 is a perfect, right, a common one that we use. So um, this becomes, I guess we gotta get A. So this part is A, and this part is B. So let's find that. So the first one was at 8 cosine 120. That becomes -4, comma, and then 8 sine of 120 becomes about 6.9. It's okay to be like that, and that makes sense because we are over here for, yeah, that's right. So we're good. That's awesome. Makes sense? I hope. All right, check it out. Next part. Using one more thing here. This one says find the magnitude and direction angle of u is 2, 3. So if we want to find that, I guess what I have to do first is I got to think about where am I at. So if I draw it, 2, 3, 1, 2, 1, 2, 3. Boom, I'm right here. So my direction angle is, so it's going to be pretty big. All right. So first, let's find the magnitude of u. Finding the magnitude of u is simply the square root of 4 plus 3. So the square root of 4 plus 9. So radical 13 is um, my magnitude. So let's get the angle. The angle we need. Let's see. I know that to get that, I have to say, okay, u is equal to u is equal to the magnitude of u times the cosine of theta, comma, the magnitude of u times the sine of theta, if that makes sense. So I know the magnitude is radical 13, and so let's use that. So u is 2, 3. So 2, 3. Let's see. U is 2, 3. So if I split it, oh, okay, I'm going to split it into parts, and that's equal to this guy right here. So 2 is equal to radical 13 cosine theta, and 3 is equal to radical 13 sine theta. So if I do this, cosine theta is equal to 2 over radical 13. And let's see what we got here. So cosine theta equals 2 over radical 13, I guess. So then theta is the arc cosine of 2 over radical 13. So let's find that. So when I do that, I get 56.3, but that is this little bit right here. So I guess I got to do 360 minus that angle. So I guess I get 303.69. So my angle is 303.69 because I'm in that fourth quadrant. So my angle, my direction angle is 303.69 degrees, if that makes sense. right? So, what are some applications of this? Some applications of this is velocity and speed. So, in case you're wondering, the velocity of a moving object is a vector because velocity has both magnitude and direction. The magnitude of velocity is the magnitude of the velocity is speed. So, the magnitude of velocity is speed. So, that's some physics for you right there. All right. So, hopefully, this makes sense. If not, we'll talk a little bit about it tomorrow, and I'll see you in class. And may the force be with you.